All right, welcome back. Hope you had a good break. I spent part of my break talking with a gentleman that wanted to adapt our last script to a different class in a different part of the world, so I thought I would start off with that. It is someone that works in the RED program, so is very interested in deforestation. So I actually did keep the exact same time intervals because didn't know what we were looking for necessarily. And the only change that I made in the script to what we did earlier is going to change the dynamic world class to be trees. And then we went to the part of the world where he does his work. So let me run that here. So if I zoom out a little bit, we're in, I'm not sure what the region of Ethiopia is, but one of the forested areas. And then we zoomed in and looked at some of the patches that it identified and highlighted a little area where we were seeing some of the change with the geometry. And then it looks like, based on a very quick interpretation of this graph, is that it was forest, and then it was converted into crops for that area. And that we can't see it in the base map of Google Maps or Google Earth right now because those don't get updated that much. But Sentinel-2, we could pick out at least what appears that it could be changed to a crop environment there. So just wanted to point that out because it was really fun to have a script that you can actually just tweak, like in this case, one line of code to say a different dynamic world class, starting with those same thresholds, and we could find something that was relatable to where somebody is working in the world already. Yes, Tanya.
Do you mind showing the link again to the script repo?
Oh, yep, I will do that.
For some new folks in the room.
That's true. Yeah, so I don't know if it was quite clear this morning when Michael was introducing it, but this does build on part one. Part two does build on top of part one. But welcome if you are joining us new, that you've been in a different session up to this point. We went through a series of scripts that gave an introduction to the dynamic world data set, allowing us to explore that data set from within the Earth Engine code editor. You can catch up and explore the scripts that we saw in part one by going to this long, not so long Google link. So goo.gle/G4G22 dynamic world, or DW. And that should bring you up to load up a code repository in the code editor that will have a series of scripts, about 8 or 10. Anybody need time to catch up where we are right there? Okay. All right, I'm going to skip ahead to, so we did a series of scripts in the first hour, and now we're going to erase those and move to, this section is not building upon exactly the scripts that we had in the first section. But they are going to introduce some concepts that I thought was useful to explain pictorially first. And we are going to demonstrate how to use dynamic world as an input into a classifier. So in a sense, even though it does have these 9 class probabilities, we're going to ignore that they are actually probabilities or probabilities for particular classes. We will just throw that information of what classes they represent away and use them just as if they were like bands that a satellite is acquiring. We're going to take those variables that we'll call the dependent variables for the classification, and then we're going to use to train a classifier to predict something that is our dependent variable, which in this case is a land use, land cover classification that comes from the Lucas survey data. And I do want to do a quick exploration of Lucas itself, because this is a pretty phenomenal data set in itself. It's produced by the European Joint Research Center, and we have a page describing it in the Earth Engine Data Catalog, same as others, and a few different code scripts. The one I'm going to open up is the second one here, that uses a technique for displaying large vector data called feature views. And I'm going to use this particularly because it's so large, the data set, that it's really important, or it's really beneficial, basically, to use this styling environment. So I'm going to zoom over to the part of the world where it is and run just this really simple script. Oh, I guess it zoomed me in. And as you can see, it's it's on a grid of some sort. The colors correspond to one of the properties that were surveyed there, but it's really, really extensive, what is being surveyed there. So let me zoom out to Spain so you can start getting an idea of like how dense it was, and then the rest of the European Union. So Switzerland, as usual, is being quite independent there in the center. But many of the countries in that area have this really rich data set that was basically people driving around in cars trying to get as close to a regular grid of a point that was identified in advance and trying to see what's going on there. And if possible, walking to the actual site and collecting information on it. So I'm going to actually open up the second one as well, or sorry, the other script here. And just explore a few of the points around in this area. It's not styled quite the same, but I can use the inspector to click on a Lucas point. And you can see for the particular point that I clicked on, there's actually 3 points there. And that's because they go back and sample the same area year after year to see if anything has changed. And then just to expand out one of those features, there is a rich set of properties that are there that they're collecting. And there were some folks from the JRC that took on the effort to harmonize the survey data over the period of, I believe, 5 years, which was a monumental work in itself to make it even more useful because the sampling protocol changed slightly between the years. But some of the stuff that's interesting in here, if it was at this particular point, oh, it wasn't. Many of them have camera images or pictures that were taken in the 4 cardinal directions. That is probably only for the points where they were actually able to get out. So I guess I should pick one that was right next to the road. That's probably the most recent, or the easiest for them to get access to. But there are, oh, there we got it finally. This point is classified, if we look onto the land cover class, as pine-dominated coniferous woodland. And at that point, there's all these pictures. So it's just an incredibly rich field survey data set that you can extract information out for land cover classification and land use classification. All right, and we're going to make use of that in this hour. So that's Lucas. That's dynamic world. We're going to simplify Lucas tremendously to get down to just a reasonable number of classes that we can kind of visualize on the screen. But you could do this for richer, a more detailed classification as well, not just the 3 classes. Then we are going to extract from dynamic world and all the images that we have at the locations of those field samples to create this training test validation data set. So that's one of the steps that we'll be showing. We're going to break that into a set of data that we can use for training a classifier. And we did a 70-30 split here and reserved 30% for testing. We're going to train a classifier there, which results in a trained classifier. I wasn't feeling very creative when I made this slide early this morning to try to explain this, but we are going to create a trained classifier that we then can use with our testing partition to do a rough accuracy assessment. This is a simple script. There is all kinds of things that are not quite correct to get a true accuracy assessment in terms of like balancing the data that is going into it. But it's just for demonstrating that it is possible, a starting point that somebody could use for developing a much richer accuracy assessment algorithm with what we're doing. But I just wanted to to take it all the way there to show that we can come up with some measurement of overall accuracy or user-producer accuracy, and then we can vary the inputs to compare those accuracies. But I wouldn't take those at face value, because it's a very simplified algorithm that we're going to have here. All right, so similar to before, there is a script that if you're in the slides, you can click on the links here, or just go to the script that's entitled 2A in the code repository that you have already open. Don't like that sign. All right, let me go back to the repository that we had open. Looks like I renamed the script recently, and I didn't update the slide, so that's why I think I was getting that error when I tried to go directly to it. But does anybody need help getting to this point of having the repository open and getting to the second to last script there? If so, raise your hand. We have, I think, the same TAs as hour one available. All right, so we have a good amount of time to get through this script, so feel free to definitely raise your hand if there's any parts that need further explanation. But I'll try to go through it in detail. Similar to the scripts we did earlier, we're going to define a time interval. In this point, I just hard-coded in the start date and end date. And then we start working with that Lucas data set. I basically have loaded those in as imports at the top of my script, so both Lucas and dynamic world, a large table and a large image collection. And here's my first set of operations working on the Lucas data set. I'm going to take the metadata and restrict it to just 1 year, 2018. And that doesn't match up with my constants there at the top, so we might have to correct that a little bit later. Because I think that was the most recent that the Lucas data set was selected that we have in Earth Engine right now. Then we do some filtering on additional pieces of metadata. There's a land cover filter. They have this letter group, A, B, and a bunch of the other letters that have definitions. I'm picking out B because that seemed to be the agricultural land covers. And then under land use, there was a particular designation 2 for agricultural land use. So it's just constraining that data set quite a bit from what it originally was. So for example, we can do in Earth Engine to examine. So we'll take the unfiltered variable here, Lucas, figure out what the size is. And then the second one, print Lucas filtered, and figure out how much we reduced it. And this will spin for a little bit while I start explaining a little bit more of the script. That didn't take too long. So 1.3 million measurements there in Lucas that we've now constrained down to about 85,000. All right. Then I went and just stored some variables to use in the labeling of storing land cover, both what Lucas describes it as, which is the Lucas land cover class property up there, and then we're going to name what the class property for what we're predicting as just predicted land cover. So we'll start examining that later after we do some classifications. And then just to make it easier to rerun things over and over, I made a function so that I can vary the name of class 1, the name of class 2, and then so we're not working with 85,000 variables in our classification, set a max samples per class for those 3 classes that I'm going to do. So I'm only defining 2 classes there, but I said that it was a 3-class classification. My other one is other, so it's like everything that is part of that agricultural land cover land use filtered data set that doesn't fall into a particular class is going to be in another class. All right, so I guess I did have a few things just to once again understand how rich Lucas is just for agricultural data. Here is a histogram calculating basically for all of the different land use classes for these agricultural classes. how prominent they are throughout the entire data set, or at least the data set once I had filtered it. All right. So now I'm going to prepare the dynamic world data set for this line 40 right here. We're going to start off with a full dynamic world data set, filter it down to a particular start and end date, and take the mean value across that entire interval. And then I'm going to get rid of that label band again, because I just want to work with the probabilities and inputs. I'm going to use a particular, well, most classifiers, they are going to expect either categorical or continuous variables, and the classifier that I'm using is going to expect all continuous variables. So we're just going to work with the probability bands of dynamic world. And that's what that group of code does there at the top. And then Lucas, as we saw when I was going through that, just looking at the data set itself, has a lot of metadata contained within there. I'm going to pull out only a few of them that are relevant to either the filter that I passed at the beginning over the data set, or what we're going to do use for the classification. All right. And then our next series of 3 different blocks here is parsing out Lucas into a feature collection here of that first class that we're looking for. So if I can describe this correctly, we have all these samples, and we're going to filter it by a filter that's looking at the label that's going to match class A, and then going to basically be setting a class description and class property on there. So a numeric value of this class property, so that because the classification expects to run on integers, but then I also want to set a more human interpretable class description for that class that we're using as well. And then, as I said before, we're going to limit it down so that we don't have the 80,000 going into the class, so it'll finish in a reasonable amount of time. Do the same thing with a second class. And then finally, there is a filter here that just looks for everything that didn't fall into the first 2 classes is going to end up in this class C. So that's how we have divided up all of our sampled points into 3 classes. And then at that point, they have been labeled, the individual classes, with these class properties and class description. And now, once they all have their own metadata, we can merge them all back together to use in the classifier. And that's what this step in 74 is. And I'm going to print out the histogram there, sample class histogram. And I'll show you the result of that over on the side. There we go. All right, so for this example that I ran, I was picking olive groves as one class and potatoes as another class. I figured this was an easy one, right? You're trying to get something that's primarily underground and something that is going to have a canopy. And then it's going to compare that against every other, or a sample of other agricultural points as well. All right, so any question about that? We're still in the preparing stage for our samples. All right, the next section right here is, is using this to generate training data. So we're going to take the predictor layers that we have from dynamic world, and then we're going to sample it at these points that we've defined above using the properties that we have labeled them with, so that it knows whether it's class A, class B, class C. Do it at a resolution of 30, and this tile scale is a mysterious parameter that sometimes we have to set if we want to get more to work or get more training data to work with the classifier. So it's basically going to chop up the default tile size into a smaller set so that it doesn't have to load as much data at the same time in order to do its work. And then down here is whether we want to transmit geometries along with that sample data or not, because by default, when we're doing these sample regions, it will just extract out the information and throw away the geometry, because that can be much more memory efficient. But we're going to do it with a small enough data set here that I'm going to set geometries to true for doing the sampling of all the dynamic world layers. All right, next section is training the classifier. As I said before, we're going to decide to train on 70% of the data and reserve 30% for doing the accuracy assessment there in order to come up with some random sampling within there. We are going to add a column called random to our training data and then filter, should say if I go on the side screen here, less than the split and greater than the split. Yeah, so less than 0.7 or greater than 0.7. So we now have feature collections here. That is what we're going to train with, and then later on what we're going to test with. We're going to use that training partition to pass it into a classifier. This one is random forest, but we could do any of the other classifiers that are in there. I haven't tried it on the other classifiers, but they should work as well. But since this is one of the standards that is used for remote sensing, I decided to go with that. With our forest size of 5. And what else do I need to explain about that? I guess not too much. We now have a trained classifier once that has gone. That is actually where our code is going to spend most of the time, especially as you start upping the amount of samples. And then once we have a trained classifier, we can go back and classify the prediction layers of dynamic world, all of those band probabilities, pass them through the trained classifier to come up with a classified image that will have 3 classes within it: class A, class B, class C. It's a little bit strange to look at. I don't know if I actually had it in here at all. But the image itself will predict everywhere, regardless of whether it's agricultural land or not. So you'll have this map that will have 3 classes, but it's really hard to interpret it itself unless you went back and had some additional information about like where the agricultural lands are or not. So I don't find it particularly useful as a visualization, and didn't put it in the script. There'll be another script later on where we actually will see the results of the classification, the image classification. All right, so now we have a trained classifier. The next step is accuracy assessment, where we're going to take our reserved 30% of sample data and classify that with the same trained classifier, and then generate a confusion matrix, which we then extract out the accuracy measure of that confusion matrix. And then as an end, I guess I displayed the points that were used for testing so you can get an idea of where the sampling was going on. So I'll start that running and go to the part of the world where I should be for seeing any results. All right, so it's not that, once we did that, limiting it to like, I believe 200 samples per class, it's not that much data and it's spread out. And this is probably not what you're gonna wanna do. You probably wanna constrain it to a local region that you're familiar with, that has training data that you trust. But just for demonstration purposes, I worked on the entire Lucas data set and randomly took those 200 points. And over here, I guess on the side, the end result here is an accuracy of 0.7. So somewhat high, I guess, at least relative to the other classes that I tried. And because I put that into a function, I can try a few other comparisons quite easily too. So the first one was potatoes and olive groves. The next one is maize and oats, which I think will be a little bit harder to compare. And the last one should be really hard, 2 different variations of wheat. By the time we get down to an accuracy, I believe, of like 0.3, that means it doesn't know anything about it. It's just random chance that it's getting it right because we have 3 classes that we're trying to predict. So anyway, this is going to run for a while, and the outputs will be over here on the side. Probably what I would do for next steps is start looking at the sensitivity of like how many points do I need until the accuracy gets stable, so some type of sensitivity analysis there. There's all kinds of other things that I would probably do is start mapping out by creating feature collections of areas that were correctly, or points that were correctly classified or not correctly classified, and actually zooming in and seeing if by visual interpretation I can understand why it's going wrong. Anyway, those are a few ideas. So any question while this, I guess it's still running. Oh, it's not running. So let's look at the results here. We got the maize versus oats comparison, and that had accuracy drop down to 0.61. And if we go to common wheat versus durum wheat, that's around the same at that point. Not sure how well I trust this accuracy yet for all the reasons that I spoke to earlier, because I don't know if this is anywhere near enough points, which I suspect it's not, in order to get kind of a true stable accuracy for the model. But that is the general flow of using dynamic world, throwing away that label information, throwing away the information of like what class means what, and just using it straight as an input into a classifier for another set of classes that do not have to match up with what dynamic world provides, those 9 classes. So at this point, yeah, let me know if there's questions about the script, questions about where you would go next. I will pause here until everyone gets uncomfortable. But I will blink first. Okay, so you guys understood that. The next one that I have is, I'm not going to go through in detail because this one that we went through was 140 lines. The next one coming up was now touching about, 360. But I did want to show you this because this is starting to add in some extra features that I didn't do in my simplified script. For example, being able to group a large amount of classes together that are similar. So like maybe in this case, it was like all of the classes that are sort of grain-like. So it's actually doing a more intelligent filtering of that original Lucas data in order to do a classification. And there's a few other variations as you go along in here. A lot of it is doing the same pattern itself, but the code is just a different example of how to get there. And this is also, Brookie's script that was highlighted this morning during the plenary. So let me just run that and get it going. Just for full disclosure, it's running very quickly and coming up with a result because it's been cached somewhere. Normally the classifications are not that quick to train. But in this case, Brookie's script has a really useful feature is that it has 2 layers. So it's converted that classified information back into layers. So you can actually start looking at a variation within the agricultural areas. And so that will allow somebody to better interpret whether a class change makes sense or not, as opposed to what I was doing where I just lumped everything else into other if it wasn't the 2 classes that I was looking at. So that you have access to play around with. Is Brookie here at this point in the audience? I don't know if he is. Okay, he's not. All right, so we are doing pretty good on time. So I am going to invite both just general questions for myself or any of the other people that are involved in creating Dynamic World about how it was created and what is the potential for its use. So I welcome anybody that has a question related to that to come up to the mic. And then I'm going to also invite Valerie to come up and show some of the apps that she has created for Dynamic World that allow you to explore things without having to go through the programming. It's nice to know what has to go on underneath the hood to manipulate Dynamic World, but when we create these Earth Engine apps, and we can hide a lot of that complexity, and Valerie has created some amazing Earth Engine apps for exploring the Dynamic World data. So any questions on Dynamic World, how it could be used? Take this opportunity because you have the engineers that have worked for years to create this.
So thank you very much for that. I don't know if you mentioned that, so if you mentioned, I'm sorry for asking again, but do you have any experience using this type of, like any engagement, using this type of solution for example, the European due diligences now, just to prevent deforestation to be embedded in supply chain? So how countries can use this type of solution to monitor the risk of the product or the commodities that are selected there to be produced in areas recently deforested or deforested after the cutoff date. So I can see that as a way of enabling countries to actually do their MRVs, especially those that are absolutely no conditions to implement something like that, like no technical staff for that.
Okay.
So do you have any experience already implementing it?
So I will give some high level, but I'm going to invite Tanya to answer that if she has more details. I would say that we are still real early stage of getting this into the hands of those groups that can tell us whether it is valuable or not for that type of work. We hope that it is. We think there's a lot of good potential, but I personally am not aware of them using it yet. Tanya might be able to add more because she works closely with the partners that are working with this data set.
Yeah, I mean, I think that's one of the things that we're super excited about. You know, could it, you know, it's not proven yet because it's still so new and it's still early days. It's just been, you know, released relatively recently. But this is also the Forest Data Partnership, you know, with FAO and USAID, and, you know, it's, you know, a broader partnership that we're trying to test to see if, you know, this data set is useful for commodity-driven deforestation. Anyone else have anything to add? Cool, thanks. Any other questions?
Yeah, I'm pretty excited to see a potential, not of these toy examples like I was putting together, like when somebody really has like classes that they want to discriminate whether Dynamic World will be useful or not. I think that it does preserve a lot of useful information, both in terms of like probabilities. It's not throwing away when something is close but not quite there. You still get that the full probability information, and then also that that temporal signature might be used for classification as well. It's like, how is it changing throughout time? Is it growing in response to rain or something like that? These advanced type of interrogations into the data, I think, they're untapped at this point, but have a lot of potential. Any other questions? Valerie, were you able to locate those? Okay. Yes. There's a mic right next to you if you'd like.
Hello.
Yep, I believe it's on.
Is there a GUI in the works to take some of the most used or most common things to, you know, just to give people a chance to really play around with it without really knowing how to code?
Okay, so the question was, is there a GUI in the works? And that is something that we can show a little bit of, like the potential, if Valerie is. Oh, I can either help you up here or they can give you a tour around the entire building to come to the backstage. Thanks.
Thank you. All right, give me a minute to get set up.
Sure, yeah. Yeah, I can talk a little bit about, I mean, this is Earth Engine in general, that it is for developers. You pretty much have to be comfortable at some level with programming, but we also heavily rely on what we refer to as Earth Engine apps as a way that you can create a simple user interface for your collaborators that don't necessarily feel that comfortable with coding. So you can basically simplify, provide them with controls where they can select layers or select a region or have drop-down boxes to indicate some type of input to an algorithm, and then behind the scenes, your code can be running. And I will walk over here while Valerie explains that one, because this is an example. Valerie has several examples of these Earth Engine apps built on top of the dynamic world data.
All right. So yeah, I will get to the one that we looked at in the plenary this morning, but I think I'm going to actually start with one that I built to give people a sense of, for those who may be a little less familiar with the Sentinel-2 orbital patterns and how dynamic world is being generated and how quickly. So this app, which is, could read out the link. It's pretty tiny up there. I wonder if this is something we could add to the slide deck after the fact.
We can, yep.
Yeah, so if folks are trying to get back to this, but this app shows the near real-time acquisition. So we are just loading up the most recent Sentinel-2 L1C data that's in the catalog and then overlaying the actual dynamic world results on top of that. And I'm going to go back in time just a little bit, so we've got a little more to look at there. But here you can see a bit more of how the data is being collected and get a sense of the results. So we can zoom in, and this one's got a lot fewer bells and whistles than the time series Explorer, but this is a great kind of first look at flipping through the collection without having to do any aggregation, and you can interact with the time slider up here. You can also go and change your month, so if we wanted to go back, see what was happening in April of this year. We got lots of cloud cover. But again, building that connection between what we see in the Sentinel-2 imagery itself and the predictions that are based on top of it. So this is our near real-time viewer, and again, we'll get those links in the presentation. But perhaps a little more interesting, a little more polished, a little more options that can be tweaked here. This is the time series viewer that Tanya mentioned and showed in the plenary. And in this viewer tool, we're able to interactively generate those charts that you were generating in the example scripts today. So as Tanya had pointed out, we can click a pixel and we can actually see for the date range that is specified down here in the GUI, the class probabilities. And what I thought was really nice was, again, making that connection back to, well, where do these come from? The map that I'm seeing on the display here is one of those composites. We've taken the most frequently occurring class over the specified date range and applied that neat hill shade trick to give you a sense of the uncertainty. But in the chart, if I wanted to say, oh, well, it's a little weird that in February we've got snow and ice, well, maybe not so weird, since Dynamic World is predicting on those individual image acquisitions. If we load up this date, you can see for this location, which I should zoom out a bit and show you where we are closer to where I live and work in Massachusetts. We are getting typical winter weather where we've got a snow-covered landscape and Dynamic World is picking up on that snowy image. And if I let that prediction load again, we will see that it was fairly snowy this time of year. And the hill shade does apply dynamically in this app, so you have to be a bit more zoomed in to see that. And if I slide this off, let this load for a second. It's been a while, so it's not all cached the way it might usually be. There we go. So we've got a snowy Sentinel-2 image. So if I go back to the dynamic world prediction, you can see we're really picking up on those places where you're seeing snow through the forest canopy. But if I were to look at a point in mid-June, here's my dynamic world prediction loading, I've got a lot more confidence relative to that that aggregate layer that this is all intact forest. areas like this and our clicked point. And if I slide this off, there's that Sentinel-2 corresponding acquisition, so no snow in this one. The other neat thing about this app is you can adjust those compositing dates. So we were adjusting them in the code. Here you can just use the GUI. So if I wanted to make a map that was aggregating over the full, well, I'm going to be brave here. We're going to go all the way back to 2016 to 2022. And if I click update, it's a bit funky for an aggregation because we're going to get the most commonly occurring class across multiple years. But what's nice is the time series chart is going to update to show that same date range. So here I'm getting a sense of each year we're getting a seasonal cycle going from forest for this clicked point to some snow cover and back again. So you can really inspect what's in the image collection, get a sense of if I'm building a composite, quickly update those and figure out if what date ranges you'd be interested in using, and really, again, tools for exploring this sort of data set. It's hard to get in there in the code editor and immediately know this is the period I want to aggregate over, or why is that looking kind of funky in the winter time? And this tool is hopefully going to help you get in there and navigate a little bit easier. You can also clear out the chart if you want a nice, more of the map visual there. And I think the last thing I'll say on this is it's been, in my experience, we had a little conversation after the first session, as a teaching tool for those of you who might be teaching courses, looking at things, at your location, your study area, the place that you're working, something that works into a lesson plan for those of you who teach at various levels. Apps can be very accessible, and you can get in there and let your students or yourself look at dynamic world and think about what they're seeing in the data set with a code-free environment. So I've used it in teaching. It's a great way to introduce classification, to look at, again, study areas, places of interest. So all around, hopefully a helpful tool as folks get oriented with this very large and very complex data set.
Thank you, Valerie. So did that give you some of the answer to? So we will produce a few, but we really hope people in the community will produce additional apps for things, different ways to carve up the data that we haven't thought of.
Yeah, I just want to add, if you want to explore yourself, there's a short link. It's bit.ly dynamic world app, all one word, lowercase, except for the bit.ly part. It's like bit.ly. And of course, in the Nature Scientific Data paper, we link to this visualization, this Explorer.
Yeah, so I'll put a closing slide at the presentation and add in these links and what other websites we want to point you towards. There's a question there in the back, if someone has the mic.
Thank you, Tanya. Yeah, I just wanted to know if you've found it to be really good at predicting oil palm, like discerning oil palm from forest, because one of the biggest issues in the tropics is that these classification algorithms think that oil palm is forest. So I don't know if you've looked into that specifically, or someone else in the audience maybe has.
So yesterday's keynote, Brian Sullivan showed an example of a layer that using a layer that came from Dynamic World that was pulling palm plantations. It used similar techniques to the ones we just saw here to create a classifier that did that. One sort of intuitive thing you can look at is when you see in a satellite image the palm plantations versus the native forest, the texture looks really different between the two. And because Dynamic World is trained using a convolutional neural network, it's taking some of that texture into account and encoding it into the pixels. Chris is going to yell at me if I get this wrong. But good ground truth is the only thing that's going to really prove this to you, but the data should be encoded in the model to some degree. The other really interesting component we've got is the time dimension here. Forests don't move. So if you're pretty confident at some point in time that this was a newly planted forest, and that's an easier thing to see because you'll see the bare ground and tree confidences switch around. Less bare ground, more trees as the canopy fills in. You'll probably see some crop prediction as well because of the rows in the planted forest. You can sort of jump back in time to a high confidence moment when you know this was likely planted palm, and then pull that apart, in that direction as well. Noel had some pretty good pointers on how to include time dimensions in trained classifiers in his talk on Tuesday, I think. So that would be a good place to start.
Sorry, this is a simple question. I'm still looking at the potatoes versus olives classification. I see that you have an input band with RGB colors, right? Is that what you're using, or can you also get like a 31 by 31 pixel image around the point that you are actually interested in classifying, so that you can see how the world looks around that?
Let me try to repeat what I thought I heard, is that we are sampling for these points, or just at a point, but not encompassing a surrounding area. Was that correct? So we definitely could modify when we are doing the sample points here collection to buffer it first. If we wanted to, use the same centroid, but then actually take a larger area for doing that sample, that it would be a short modification to the script. And that would potentially cut down some of the noise for places that are very homogeneous, I think, or depends on the scale of the variability, but if they were homogeneous within a buffer that you could define. So does that answer your question of just how we would go from a point? Okay, thanks. Any other questions? We have one towards the front here.
Hi, thanks. So thinking about using this for biodiversity modeling, this kind of secondary classification, I think would be super useful, because it's important to know what is a forest and what's a planted tree, for instance, and that sort of distinction. So we've been exploring this type of thing, and it's going to be super useful having this script that you gave us and use it from there. Okay. But I was wondering also about future directions. Is there a tier 2 in mind that sometime in the future, I know it's early days and this is already a lot, but I was wondering, is there something on that line coming in a few years, maybe?
Okay, I will pass that off to the program manager for Dynamic World, right?
Yeah, I mean, right now the future direction, right, is sort of a little bit what I talked about in the plenary about, increasing the number of useful pixels, right? That said, we care a lot about biodiversity monitoring as well. So, really want to hear some of your ideas and some of your, your direction and where you think it can apply.
We do have potential.
I mean,
Yeah, we do also have potential of cleaning up some of the Sentinel data that is actually feeding into Dynamic World, getting better on the cloud shadow classification, which would result in a more powerful or more useful Dynamic World. So that's another area that we're thinking about. Any other questions? You got one? Nope, okay. All right, if there's no other questions, then I guess we will call this a wrap for the hands-on session. Feel free to still track down, if you didn't want to ask your question to everybody in the room. The individuals that might be able to answer it are still here, waving on the side. So thank you all for coming and taking part, and we welcome your feedback on how useful Dynamic World turns out to be for your work. Thanks.